Hello students. So in this video, we're going to start with the new chapter, that is areas related to circles. We're going to start with areas related to circle. Okay. Now let's first understand what is the meaning of area. Okay. Area is basically a region uh, inside a given figure. Okay. Let's say let's take any random figure. Let's take a rectangle or a square. Okay. Now this is a square. Inside the square, you can see there is a region, right? I'll just shade it in yellow color. You can just see this yellow color. I'm sorry. Let me do it properly. Or let me take green color itself. See, I'm just shading this region, green color region, okay, is actually called as the area. Okay. You take any figure, the region inside that figure, okay, as I'm shading here. Okay. So this region, the green color region or the portion, okay, we call it as area. So this is area of a square. Now the chapter is area related to a circles. So we're going to concentrate only on circles. So I hope you understood the meaning of area. Area is simply a region inside a given figure. Okay, plane figure. Okay, that is a two-dimensional figure. Two-dimensional in the sense the figures that we draw it on the paper. Okay, like circle, square, rectangle, all those stuff. Remember, we draw ball on the paper like this, isn't it? Usually, this is just a 2D representation, but we cannot draw a ball on the paper, isn't it? That is, you cannot draw a sphere on the paper because sphere, the ball, cricket ball, it's a three-dimensional figure. You cannot draw it on the paper. You simply draw the two dimension of it. Okay, I can say the projection of it. That's what we draw. Okay, so let's not get in deep. So simply the area is simply the region inside a given plane figure. Okay, now so as we discuss, we'll be discussing only about circles. Okay, now first let's recall certain terms related to circles. Okay, so I hope you guys know what is circle. A circle is a plane figure. A circle is a plane figure such that it has got a fixed point. We call this fixed point as center, and it has got a fixed distance. This fixed distance is called as what? Radius, isn't it? Fixed point is called as center. And few terms, I'm sorry, few terms related to circles. Okay. The first important thing is chord. What is chord of a circle? Chord of a circle is simply the line segment. If I take this, let's take a point somewhere here. Okay, let's take it as Q. Okay, it is the line segment that is joining the 2 points on the circumference of the circle. Circumference is basically the outer part, the boundary. Okay, this part, outer part is known as the circumference. Okay, let me trace it in the red color. Okay, this thing which I am tracing, that is called the circumference. Okay, so you take any 2 points on the circumference, join these 2 points, the line segment that we get is called as the chord. So what is chord? Chord is the line segment. It is the line segment joining any 2 points on the circumference. Joining any 2 points on the circumference of a circle. Okay, and what is a chord? It is a line segment joining any 2 points on the circumference of the circle. Now if you remember, let's draw a diameter. Okay, let's take a point M, N, and you guys very well know that the diameter passes through the center, isn't it? Let's take the center to be this. Now if you observe, M and N are 2 points on the circle, isn't it? Now, but they're also passing through the center. So Mn is basically a chord. Okay. Now we have given a specific name for this. We have given it as diameter. Okay. Now, so what is the diameter? Diameter is also a chord, but it passes through the center. If the chord is passing through the center, then that chord is called as diameter. Okay. So what is diameter? Diameter is the chord, or you can say the chord that passes through the center of the circle. The chords that passes through the center of the circle, through the center of the circle, are known as diameters. Okay. The chords that passes through the circle are known as diameters. Okay. So what is the difference between diameter and chord? Basically, diameter is a chord itself, but it passes through the center. So let me draw another one. If I join Q and N, what does Qn? It is a chord because Q is on the circle, N is on the circle. Join it. What do you get? You get a line segment that is called as chord. Pn, again it's a chord. Mp, again it's a chord. But if I draw something, a new thing like this, let's say Px. The Px becomes what? It is a chord, but it is passing through the center of the circle. Therefore, it's a diameter. Okay. So this is regarding the chord and the diameter. And chord is also known as the diameter is also known as the biggest chord, isn't it? So let's take another circle. Okay. Now, again, let's say O is the center of the circle. Again, let's take 2 points on the circle. Okay. Now, a part of the circle is called as arc. Okay. A part of the circle. Let me trace it. Now, see, between A and B, you take only so much. This is just a part of the circle, right? It is not the complete circle. So this part is called as arc and it is smaller in size. So we call it as minor arc. So what is arc? It is just a part of a circle. Part of a circle between 2 points on the circumference. Between any 2 points on the circumference. Between any 2 points on the circumference. Okay. So what is an arc? Arc is a part of a circle between any 2 points on the circle. If you observe, let me draw in another color. So let me draw in blue color. See, the one which I'm drawing in blue color, that is also an arc, right? Only the blue part. Just focus only on the blue part. I'm sorry. Just focus only on the blue part. Okay. This is also a part of a circle. It's not the complete circle. Let me draw it the other way. Okay, I mean another place. It is like this, right? The blue color, it is like this. It is just a part of the circle. It is not the complete circle, right? It is not the complete circle. So again, this is an arc. Okay, the bottom one, it is like this. Again, that is also an arc. If it is a part of a circle, then we call it as an arc. Okay. Now coming to the very, very important topic, that is segment and sector. Let me erase this. Okay. Segment and sector. What we'll do is let's take 2 points on the circle A, B. Let's join it. So what is AB? Chord. Now if you observe here, the bottom part, it's just an arc, right? It's a small portion of the circle. We call it as an arc. Now between this chord and the arc, there is a region. Okay, let me shade it in green color. This region, which I've shaded in green color, is called as segment. Okay. Now, above also, if you observe above, so there is a region right here, as you can see. Let me shade it. Okay. Now that is also segment, right? Because AB is the chord and the bigger one is my major arc, right? So the bigger in size is called as major arc, the smaller in size is called as minor arc. Okay. Now, the region between major arc, okay, let me share it. Okay. Yeah, it's fine. Now, the region between major arc, which is our major arc, this will be the major arc, right? This is our major arc. Major arc and the chord is called as major segment. Okay. The one which I've shaded in purple. The green color which I've shaded is minor segment. Okay. So basically segment means it is the region between the chord and the arc. If it is between minor arc and the chord, minor segment. If it is between major arc and the chord, then it is major segment. Okay. So similarly, the next topic is sector. Sector of a circle. Okay. So what is sector of a circle? Sector of a circle is simply a region between two radii. Okay. Let's say O is the center. So OA is a radius, as we know, and OB is also a radius. The bottom part AB is minor arc. So between this minor arc and the radius, okay, and the radius, we have got a region, right? Let me shade it. Okay. Let me shade it. So this region, okay, this region, this is between two radius and the arc. Which arc? Minor arc. So it is called as what? Minor sector. Okay, remember sector is like a cake shape or a pizza shape. Okay, so remember this. A sector is between two radius and arc. Okay, whereas segment is between chord and the arc. Between chord and the arc, it is segment. Between sector and the arc, between radius and arc, it is sector. So if it is minor arc, minor sector. If it is major arc, then it is major sector. So let me shade the major sector. As you can see, the top one is which I'm shading. You got major arc, okay, and between two radius. I'm just roughly shading it. Okay, so this region is called as major sector. Okay, this region is called as major sector. Okay, so what is major sector? Major sector is the region between two radii and major arc. Okay, so if you observe, the top one is major arc and it is known as major sector. So this is the difference. Please observe. If you observe sector, it's like a pizza shape, isn't it? But if you take the chord, it's not like the pizza shape. Okay, the segment. So please understand the difference between the segment and the sector. Okay, so these are the basic things that we need for this chapter. Okay, we should know the meaning of chord. We should know the meaning of diameter, arc, segment, and sector. Okay, now what we'll do is we'll list out some important formulas that are required, okay, to solve the problems. Okay, whichever I remember now, I'll post it here. Okay, later when solving any problem, if we need some more formula, we'll write it there also. Okay, so let's start with few formulas that are required. Okay, so let's start with formula. Okay, please note it down in a sheet of paper and you can post it on the wall, paste it on the wall. Okay, it will be very useful. Okay, and if you practice all these formulas every day, within a week you will remember this. Okay, it will be in the tip of your tongue. Okay, now let's start with the first one, circumference of the circle. Okay, circumference of the circle. What is circumference of the circle? Circumference of I hope you guys know the meaning of circumference. It is the boundary of the circle. Okay, so the length of the boundary of the circle is called as circumference, or we also call it as perimeter of the circle. So it is given by 2 pi r. Okay, or you can also use this formula pi d. Okay, so remember there are two formulas for the circumference of the circle, 2 pi r or pi d. How did we get pi d? See, 2 pi r can also be written as 2r into pi, right? I've just rearranged. What is double of r? So 2 times r is what? Diameter. So d into pi is what? Pi d. Okay. So that's how we got the formula. So remember, what is circumference of the circle? Circumference of the circle is given by the formula 2 pi r or pi d. Okay. So let's come to the next one. Areas of the circle. Okay. Area of a circle. Let me write it here. Area of a circle. So area of a circle, I hope you guys know the formula. Area of a circle is what? Pi r square. Okay. So if it is area of semicircle, let me write it here. I've got space. Area of semicircle. Area of semicircle will be what? Half, because it's semicircle, right? So half pi r square. Okay. So let's get into the next one. Area of a square. See, square, why are we talking it here? Because in certain problem we need this. Okay. Area of a square is side into side, isn't it? Area of a rectangle. Okay. Area of a rectangle. Area of a rectangle is length into breadth, isn't it? So the next one, fifth one. Okay. Area of an equilateral triangle. All this will be needing it. Area of an equilateral triangle. What is an equilateral triangle? It is a triangle in which all the three sides are equal. Area of an equilateral triangle is equal to root 3 by 2 into side. Very, very important. We'll be using this formula in many cases. Okay. So coming to the next one, the sixth formula. Okay. Area of circular ring. Okay. What is a circular ring? Let's take two concentric circles. What are concentric circles? Circle with same center but different radii. Okay, something like this. I'm sorry. Let me draw it properly. Okay. Okay, it is looking like concentric circle. Yeah, now it's fine. Okay. Now we have got two circles with same center but different radii. Okay. So we have got two circles with same center but different radii. Now between these two circles, there is a region. Okay. Let me shade it. Let me take a different color. Okay, let me shade it. See this region which I am shading it. That is actually known as the circular ring. Okay. So how do we find this area? This is the thing that we have to find. Okay, the region that I have shaded. Okay. Now, how do we find it? It's very easy. Let me make the border bit thick. The outer circle. Okay. This is the outer circle, and this is the inner circle. Okay. So the red color region is known as the area of the circular ring. How do we find it? It is found using this formula. Okay. Area of the circular ring is given by this formula. Once again, area of the circular ring is given by pi into capital R square minus small r square, where capital R is radius of bigger circle or outer circle, radius of outer circle or the bigger circle. Small r is radius of inner circle. Okay. Radius of inner circle. So how did we get it? It's very simple. See, when you find the area of the bigger circle, when I say area of the bigger circle, it is the complete thing, right? Let me shade it. Okay. I'm sorry. Let me shade it in green color. When I say area of bigger circle, it is this complete thing which I'm shading, isn't it? The complete thing. In this complete thing, or let me shade it in red color itself. Okay, that will be fine. Yeah. Now let's say when I say area of bigger circle, the inside part will also be shaded, isn't it? So this complete part, okay, this complete thing that I've shaded, now nothing is visible, right? So completely I've shaded. So this is what area of the bigger circle. You can see the bigger circle, isn't it? You can easily see the bigger circle. Now, whatever the region is inside the bigger circle is the area of the bigger circle. In that area of bigger circle, the middle portion, okay, the middle portion is not required. Okay. So what should we do? If you don't need the middle portion, we have to subtract it. See, when you subtract it, you get the area, required area, isn't it? So that's how we got the formula. So what we did was we found the area of the bigger circle. What is area of bigger circle? Pi capital R square. In that we don't need the inner circle, isn't it? So inner circle area is pi small r square. So we have to subtract it from the bigger one. We have to subtract the smaller one. So what is common? Pi is common. So we'll be left with capital R square minus small r square. That's how we got the formula. Okay. So now remember, area of circular ring is given by the formula pi into capital R square minus r square. Okay. So let's get into the next one. Area of minor segment. Okay, let's take area of minor segment. Okay, now in all this area chapter, what we are going to, in all the problems of this chapter, what we are going to do is we are going to find area of a bigger thing and we are going to subtract things which are not required. We'll always find the area of the bigger thing in the figure, okay, which is known to us. Okay, we'll always find what is known to us. See, let me explain with this figure. Let's take a circle. Let's take a circle. Okay, and let's take a chord. Let's take a chord. Let's join this. Okay, before getting into this, let me give another formula. Then let's get into the segment. That will be perfect. Okay, let me erase this. Let's come to segment later. First, let's understand area of sector. Okay, then we'll do it. So area of sector. So seventh one. Okay, area of minor sector. Area of minor sector. Area of minor sector is actually given by a formula theta by 360 into pi r square. Okay. Now let's say you got a circle. Okay. Let me draw properly. Let's say you got a circle. And let's take two radius. One is OA, the other one is OB. OA and OB. Let's say the angle formed here is theta. Okay. Then if you want to find the area of the minor sector, that is the thing which I'm going to shade now. This is minor sector, isn't it? This region which I'm shading, which I'm striking, that is minor sector. How do you find it? Theta by 360 into pi r square. Okay. Now, how do we find the area of major sector? Area of major sector is the same thing. Okay. Here, see, if it is a minor sector, then theta will be less than 180 degree. Okay. Now, if it is a major sector, it will be more than 180 degree. So you're going to use the same formula, or you can use this formula. Okay. 360 minus theta by 360 degree minus theta by theta 360 degree into pi r square. Remember, they have given this angle, okay, but we are trying to find the area of major sector. Let me shade it in green color. This area, okay. So the formula remains the same, okay. Theta by 360 into pi r square, but theta is in the which place? Minor place, right? Theta, the value that they have given is in minor place. So we have to find this angle actually, which I'm tracing it. How do I find it? Reflex angle, right? So the total is 360. If you subtract theta, you will get the reflex angle. So that's why we take 360 minus theta by 360 degree into pi r square. Okay. So that is, let me shade it properly in black color. See, this is the angle. If you want to find the major sector area, then you need this angle, which I'm shading it. But what they have given us the bottom one. They have given this bottom one. How do you find the top one? It's very simple. The complete angle is 360 degree. In 360 degree, if you subtract the bottom one, you get the top one. That is the reflex angle. That's why we are doing 360 degree minus theta. Okay. Now let's come in. Let's understand the area of minor segment formula. Okay. So let's take the formula. Now, as you can see, I've taken a chord. Let's say this is the center. Okay, what we'll do is let's join OA and OB. Okay, so as you can clearly see it, we have got a triangle here. OAB is the triangle. Now, let me shade. I'll shade a part of the circle. Try to find what is it. Okay. I'm just shading a part of a circle. Okay. The part of the circle is what? Or let me make it a bit easy. Let me do it like this. So it will be a bit, you can understand easily. Let me do it like this. Let me shade only the triangle. Let me shade only the triangle in green color. Okay, it is actually blue color. Let me take green color itself. I'm sorry about that. See, I just want to show the difference. Okay, let me shade only the triangle. Okay. I'm just shading the triangle in green color. Okay. Now let's shade the required area. That is the segment, right? Minor segment. Let me shade it in red color. As you can see, whichever I'm shading, that is the segment, right? Isn't it? That is the segment. Now, very clearly, the green area plus the red area gives you what? Just look at the figure. Green area plus the red area. Green area is what? Triangle, right? So the area of triangle AOB, plus area of minor segment. Okay, area of minor segment, that will be equal to what? Just analyze it. The green area and the red area. If you observe carefully, the green area and the red area, let me shade it different color. The green plus red gives me this complete thing, right? The green plus red, if you add both, you get this complete thing. Green area plus red area. If you added, what you get? You get this complete thing which I've shaded in yellow. Now observe this yellow. Does it look like a pizza? If it is looking like a pizza, what it is? It's a sector, right? So if you add the area of the triangle and the minor segment, what we get is area of sector. Which sector? Minor sector. So here, if you observe, let me write it properly. Okay. So what we did was, we added the green area with red area. What is green area? Triangle. Area of triangle AOB plus area of minor segment. Okay. If you add both, we clearly got to know that we'll be getting area of minor sector, isn't it? We'll be getting the area of minor sector. Now, what do we need? Actually, we are trying to find the formula for area of minor segment. Therefore, area of minor segment will be equal to what? Will be equal to area of minor sector, minus, send that the triangle area the other side, area of triangle. So that is the formula. Okay. So what is the formula for area of minor segment? It is area of minor sector minus area of triangle. Here it is triangle AOB. Okay. So area of the minor sector minus area of the triangle. Now you can also understand this in a different way. Okay. Let me also put that idea here. Okay. Now say suppose, let me erase all the stuff. Okay. Now let me join again. Okay. Let me join again OA, OB and AB. See, if you find this complete area which I'm shading, what is it? Sector, isn't it? It is sector. In that complete area, if you erase this, okay, if you take away the triangle part, what are you left with? You are left only with the bottom part, right? What is this bottom part called? A segment. That is the formula. If you find the area of the sector and if you simply remove the triangle, what you are left is area of the segment. Okay. So that's how we get this formula. Now, how do we get the major segment? So it's very simple. See, minor segment is this area, right? Major segment is the other one, which I'm shading it like this. Now, how do you find the area of the major segment? Very simple. Find the area of the complete circle and subtract this. If you subtract it, if you find the area of the complete circle and subtract the minor segment, you will get the answer. Okay. Therefore, area of major segment will be equal to area of the circle, minus area of minor segment. Okay. And let's come to the next important formula. Distance covered by a circular wheel. Distance covered by a circular wheel in one rotation or one revolution. One rotation. That will be equal to how much? Guess it. It will be equal to the circumference of the circle. See, let's say the tire is here. This is the wheel. Okay. Now, after, let's say the starting point is this. Okay. When do we say it is completed one rotation? It is starting. Now, as you start to rotate it, if it comes back to the original position, let's say it has come back here. Okay. Now, from here to here is the distance traveled, isn't it? Now, suppose if you cut this tire, okay, and if you spread it, it will be equal to this length, right? Or I can say it in other words. See, let's say this is the starting point. After one rotation, it comes here. In this one rotation, each point on the circle would have touched this road, right? Isn't it? So this length is actually equal to this length, right? So therefore, we can say that circumference of the circle will be equal to the distance covered by wheel in one rotation. So circumference of the circle is what? 2 pi r. So in one rotation, it is 2 pi r. For n rotation, it will become n into 2 pi r. Very simple. For one rotation, it is 2 pi r. For n rotation, how much it is? So n into 2 pi r. Okay. So let me write that also. Distance covered by circular wheel in n rotation. Very important formula, which will be using to solve few problems. Distance covered by circular wheel in one rotation. In n rotation. Okay, n rotation, that will be equal to n into 2 pi r. Okay, so let's start with the problems. So we have discussed the important formulas. So in the next video, let's start with the problems. Thank you, students.